This is section 3.6, part 1, where we're going to state if a product of matrices is defined. So the word product tells you we're going to be multiplying, and so we want to find whether that product is defined or not. So what does that mean? Well, sometimes two matrices can be multiplied together, sometimes they can't. If you can multiply two matrices together, their product is defined. If you can't multiply two matrices together, then their product is not defined. So the big question is, how do you know if you can multiply two matrices together? Well, I've got this little rule here in red, which is a nice little sentence that's going to tell us whether or not, or when we can multiply two matrices together. So it says the number of columns in the first matrix must match the number of rows in the second matrix. That's your rule. So you got to make sure that those two numbers are identical. They're exactly the same. If they are, your product is defined and you can multiply. If they're not, the product is not defined and you can't go on. There's no multiplication. So let's take a look at our first problem. All right, make sure the rule is still there for the first problem. So what you need to do is you need to state the dimensions of each matrix. And remember, the dimensions of a matrix is rows by columns. Rows by columns. So I've got this first matrix here. What are the dimensions? Rows. We've got 2 rows and we have 2 columns. So it's 2 rows by 2 columns, or a 2 by 2. What are the dimensions of the second matrix? Well, it's still rows by columns. So we have 2 rows by 3 columns. So it's 2 by 3. The number of columns in the first matrix must match the number of rows in the second. So when you write the dimensions in the matrices, these middle 2 numbers should match. If they do match, then our product is defined. So I'm simply going to say yes, the product is defined. So if we were going to go on and multiply these 2 matrices together, we could do that. All right, but that's not the point of this part. All right, all we want to do is say whether it's defined or not. We'll multiply matrices in later parts. So let's go on to the second problem. Number 2. Here we don't have an actual matrix, they're just giving us the dimensions. So we see the dimensions of the first matrix, which is 4 by 3, 4 rows by 3 columns. Our second matrix is 3 by 2, 3 rows by 2 columns. We're going to analyze these middle 2 numbers. Alright, the columns of the first matrix are the same as the rows of the second matrix. So again, our answer is yes. The product is defined. So if we were to multiply 2 matrices together that had these exact dimensions, we would be able to do that. So we'd be able to go on. Let's look at the third one, where we've got matrix A, 3 rows by 4 columns, so it's a 3 by 4 matrix. Matrix B is 3 rows by 2 columns, or 3 by 2. Analyze the columns of the first matrix and the rows of the second matrix. Are they the same? And they're not. These two are different, so our answer is no. The product is not defined. So if we were asked to multiply 2 matrices with these dimensions, we would not be able to, so we would have to stop. Just say product's not defined, can't go any further. Okay, so that's how you state if a product of a matrix or 2 matrices is defined.